This is the screencast for section 2.2, example 7, finding end behavior models. Well, in example 6, you saw how the leading term of a polynomial is the most important term for really, really large x values, either positive large x values or negative, small x values, but for absolute value of x large. So we need to find an end behavior model for these rational functions. Well, if we look at the numerator and denominator separately, the numerator's important term is 2x to the fifth, and the denominator's important term is 3x squared. So the end behavior model of f of x is y equals 2x to the fifth over 3x squared, which simplifies to be 2/3 x cubed. So what I did then is I took y1, the rational function, in full, and then in y2, the end behavior model, and I found a window large enough, like a really, really large window, to make the two graphs look the same. They look very different until you get big enough so that it's kind of like until you squint, you can't really see the difference between the two. They're graphing to be the exact same function. Part B, again a rational function. In the numerator, the important term in this polynomial is 2x cubed. In the denominator, the important term is 5x cubed. So therefore, the end behavior model is y equals 2x cubed over 5x cubed, which reduces to 2/5. So it's really just a horizontal line. So I just did a zoom 4. I put in y1 g of x and in y2 2/5, and it's just a horizontal line. Now we've got a vertical asymptote in here, and actually the g of x graph does overlap the asymptote at some point, but that's okay. As we go really, really large, and both to negative infinity and positive infinity, the asymptote takes place where the function will approach forever and ever and ever, and y equals 2/5 models that end behavior. Number 43. Part A says find a power function end behavior model for f. Well, the end behavior model of f of x is y equals 4x cubed over x, which then simplifies to be 4x squared. So it's parabolic, actually, which then means in part B that we don't have any horizontal asymptotes. If the end behavior is parabolic, there isn't going to be a limit as x approaches infinity of a constant value. Now I want to show you this on the calculator. So in y1, I put 4x cubed minus 2x plus 1 over x minus 2, and then in y2, I put the end behavior model 4x squared. Now when I graph it first, this is just zoom 6, they look nothing alike, and not only that, but look at the original function. It goes down to negative infinity. I thought it was supposed to have a parabolic end behavior. Well, remember, you have a vertical asymptote here at x equals positive 2. Don't forget about that. So you don't know what's happening to the right of that asymptote yet. So hit trace on your calculator, and then see what happens to your y values as your x values cross over that asymptote at positive 2. Look how high they go, 139. So I'm going to go to Window and set my y max to, I don't know, maybe 150. And now I can start to see the parabolic end behavior taking place, but my window still isn't big enough to really see the two of them together having the same shape. So I'm going to keep going. I'm going to change my x-min, x-max, and y-min, y-max. And now finally, with, trust me, tons of playing around with windows, I did finally find a nice window where I can see the two take virtually the same shape on the graphing calculator.